Okay guys, so today we're going to talk about function review as our first unit. And so we're going to start off with some pretty important definitions here. Specifically, we're going to talk about domain and range to start. Okay, so the domain of a function has to do with all possible values we can plug in to our function, called the input. And this is usually when we're using equations with x and y. X is usually our input, y is the output. Okay, so our domain are usually the possible x values. Okay. The variable x, or input variable, whatever it may be, is called the independent variable. We get to pick it independently. Okay. Next is called the range. The range has to do with all possible output values. So this usually has to do with y, or in function notation, f of x values. So this is the values we get back out of our function when we plug into values for x. Okay, so this is usually our y's here. That variable is called the dependent variable. Its value depends on what we plugged in for the independent variable. What we plugged in for x determines what we get back for y. Okay, so a relation is an equation or inequality that has two or more variables. So some easy examples might be like an equation of a line, y equals 2x plus 4. It could be something a little more complex, where we have multiple variables, y equals 2 times x times y. Well, not y, sorry. 2 times x times z, etc., where we have more than one variable, but there is a relation defined between x, z, and y, that y is equal to double the x and z multiplied together, etc. So a relation, it has to be an equation. It could also be an inequality, like y is always less than 2x, etc. Okay, so this would be a relation. Okay, more importantly, what we're talking about in this chapter is functions. Okay, a function is a specific relation where each input x has exactly one output y. Okay, so in other words, all functions are relations, but not all relations will qualify as a function. So what does this mean? A specific relation where for each input there is exactly one output. Okay, so this is a little bit of a side note here, but hopefully this helps show you the difference between these two. Okay, so let's say we're taking a look at a menu board, and you can think of this as kind of being like, you go to a baseball game or something and you want to order some items and their prices are over to the side. So we've got hamburger, $5, hot dog, $4, large drink, $4, soft pretzel, $3, right? You can also think of this order as kind of mimicking the way we write ordered pairs or coordinate points when we're graphing, x comma y. So our items here has to do with x and our prices have to do with y. Okay, so when we look at this menu board, is it okay that hot dogs and large drinks both happen to be $4? That seems okay, right? I mean, it's okay for multiple items to happen to be the same price. And so what we can take away from this for functions is that repeated y values, so having 4 twice, is okay. And in fact, each of these different items all have one specific price, so this qualifies as a function. Okay, so this is a function. Okay, let's take a look at a second one. Okay, so here's a different menu board. It's pretty much the same, except down below we've now added hamburger again with a second price, $4 rather than $5. Is it okay for them to be charging some people $5 for a hamburger and some people $4 for a hamburger for the same exact item? No, right? We'd say something's not functioning there. And in fact, for this one single input, the same input of hamburger, we have two different outputs, two different y values. This is not a function. Okay, so for any given item or input, there should only be exactly one output. So let's take a look at one last example here. So this time our menu board, everything is the same all the way down to here, but I've added hamburger on again. But this time, hamburger matches the same price as above. They are both $5. Is that okay? I mean, obviously it seems kind of unnecessary to have it listed on there twice, and that is true. This is an unnecessary relisting of the same exact item and the same exact price. But would that be okay other than it being unnecessary? And the answer is yes. Okay, so if you do have a repeated x value, or x item, if the y values are exactly the same, it's okay. That would still qualify as a function. We've just listed the same value or same point on our graph twice. That would technically be okay. Okay, so let's determine if each relation shown in a table is a function, with hopefully our new understanding of what a function is and isn't. So as we look at this, remember that x comma y, you can think of these as just like the same way we'd write ordered pairs if we were graphing points. And again, we can think of this kind of like that menu board we were just talking about, where x's relate to our items and y relates to our prices. Okay, so is this a function or not? And the first thing I notice about this is our input value of 2. We have the same item listed twice here, 2 and 2, and it has 2 different prices. Is that okay? Would this be a function? No, this is not a function. Excuse my n's looking like h's. Okay, not a function. Okay, let's try another example. See if we can use the same idea. Here's another table, again listed vertically with our items on the left, prices on the right. Would this qualify as a function? Now notice that all of our items are the same price. You know, if we're thinking in terms of dollars, they're all $4. Is it okay that all of these different items happen to be the same price? Kind of like drinks and hot dogs were both $4. Yes, this is a function. Remember that repeated y values are okay, but the same item can't have 2 different prices. Okay, our last example here in this section, again, we can see we've got some items down here, and I do, once again, see this repeated item. However, it has the same price. Is that okay, other than it being an unnecessary repeat? Yes, this is also a function. Okay, so a red flag is repeated x values, but we need to check if the y values match, it's okay. If they're different, not okay, not a function. Okay, a visual way to test if a graph is a function is called the vertical line test. The vertical line test says if any possibly drawn vertical line intersects a graph at most one time, so it won't intersect more than once, it'll only intersect once or no times at any value, then we'd say it passes the vertical line test and is a function. For that given x value, where that vertical line would be, it's only touching our graph once. It only has one price, okay, or one output. So let's take a look at some examples here. Okay, so determine if each graph passes or fails the vertical line test, and if it is or isn't a function. Okay, so here's our first graph. We've got this nice curving polynomial here. So imagine you were drawing in a straight line. So if you drew in some sort of straight line, and we'd look for where that line intersects my graph. So it looks like it's intersecting my graph right here, this one point. That's where it's intersecting that curve. Now imagine if I were to be able to grab that line and move it left to right. Okay, you could probably tell, sorry for some of the editing here. But anywhere I move this line, it's only going to be touching my graph once. Okay, so if that's true, we only have one output for any x value, for any input. This would pass our vertical line test. So in this case, we would say this passes the vertical line test. It's only touching at most one time, and therefore it is a function. Passes the vertical line test and is a function. Okay, let's look at a second example here. Okay, so here's our second example. Again, if we were to try to draw in some form of a vertical line somewhere, so you can pick anywhere you'd like, but if we were going to draw in that vertical line, is it possible to have it intersect our graph more than once? And hopefully you can tell on this ellipse or oval here that yes, that vertical line is intersecting twice. So for this given x value, 1 point whatever this is, there are 2 different y values. There's 2 different prices for this item. So you can think of this as x being our items, y being our prices. For that particular item, there are 2 different prices. This is not a function. So we'd say this fails the vertical line test and is not a function. Okay, so if we have a graph, this is the nice visual way of testing whether something is a function or not. For any given x, for any vertical line that we could draw in anywhere, it should only intersect at most one time. There should be just one individual price. Okay, in our next section here, we're going to talk about evaluating functions, so finding the value of a function. Make sure that we're always using parentheses when we do substitution, and of course follow order of operations once we're trying to simplify. So first thing to remember is when you see f of x, this is really the same thing as y. I mean, we could have given you this, y equals 3x minus 5. It means essentially the same thing. This is just notation to tell us that this is a function. It's called function notation. So it's asking us to find the value of f of negative 2. So what do you suppose that means? You could go back most basically and think about, well, here it says f of x, here it says f of negative 2. I no longer see x, instead they put negative 2, so it's giving you a good hint there that we want to replace x in our function with negative 2. This is the value to input into our function. So plug in negative 2 for x and basically find the value of y, find the value we would get. So this is the way we could notate it. F of negative 2 equals 3 times negative 2 minus 5. So again, make sure you're using parentheses when you substitute in. So 3 times x, 3 times negative 2. And we're not going to do any math here on the left. That was just notation to tell anybody what we're doing. All the math we're going to do is on the right. So we're going to multiply 3 times negative 2. Remember to multiply before you add or subtract in your PEMDAS. And then subtract 5. So we get negative 6 minus 5 more gives us negative 11. So when we plug in negative 2 into our function, we plug in negative 2 for x, we get back negative 11. And in fact, we know even on the graph, if I plug in negative 2 for x, we get negative 11 back for y. But this is the value, you have to excuse my box here, this is the value of our function. This would be the answer, negative 11. We plug in negative 2, we get negative 11 back. Now, let's take a look at a second example here. Slightly more complicated, but same idea, so hopefully this will go a little faster. For this particular function f of x, plug in negative 5. So again, if we're notating on the left here, just to make our work look a little bit nicer, we need to do negative 2 times, again, parentheses here, negative 5 squared plus 3. Again, we're replacing x here with negative 5. Make sure we use parentheses. So now order of operations is a little more difficult. I can't simplify inside parentheses, but we have an exponent we need to evaluate first. Negative 5 times negative 5 times itself twice. Positive 25. Okay, multiplying is our next one before we add. Negative 2 times 25 is negative 50. And then finally we can add or subtract here. Negative 50 and positive 3 gives us negative 47. So again, when we plug in negative 5 for x into this function, we get back negative 47 for y. So if we were graphing, we know this point would be somewhere on my graph. Left 5, down 47. These are x and y values. Again, this the points you don't need to write as your answer. That's just stressing what this really means. Negative 47 is the answer we're looking for here. Okay, one last section. Okay, last section. I know this is a little bit long. Definitely pause the video if you need to write stuff down. Okay, function operations, adding, subtracting, and multiplying. We're not going to do dividing yet. Again, make sure you use parentheses when you substitute in values or expressions. Okay, so it has some directions up front. It's giving us 3 functions. F of x equals 3x minus 5, a function called g of x, which is 2x plus 4, and a third function called h of x. So the reason they're using these different letters is just so we know which function it's talking about. Okay, so it wants us to answer a couple of questions. Okay, so our first one wants me to do an operation with our functions. In this case, you can tell here that it wants me to add f of x and g of x. So this is some notation I'm not a big fan of, but you do see this notation a bit. And what this really means is exactly the same as f of x plus g of x. Just add our 2 functions together. So what we're going to do is we're going to substitute in for f of x, 3x minus 5. And of course, we're going to put parentheses around it because we're substituting in for f of x. And we know g of x is equal to 2x plus 4. So with parentheses, we can substitute in 2x plus 4 for g of x. So we put parentheses in case we need to distribute or do any exponents on the outside of these. In this case, there's nothing to distribute, so we can simply ignore the parentheses. And now we can combine like terms. 3x and 2x gives us 5x. Negative 5 and positive 4 gives us negative 1. Our answer when we add these two together is 5x minus 1. Okay, let's try our next example. This time it wants me to subtract g minus f, and that order is definitely important, so make sure that you're following the correct order here. So this again is the same as g of x minus f of x. So where g of x is 2x plus 4, so we'll put that in our parentheses, minus f of x, which was 3x minus 5. This time we do need to distribute this negative sign. So this becomes negative 3x, and a negative times a negative makes a positive. So this becomes positive 5. And now we have nothing else to distribute, no exponents to evaluate there. So now we can get rid of our parentheses and now combine like terms. 2x and negative 3x is negative 1x. 4 and 5 make 9. Negative 1x plus 9 is our answer when we subtract in that order. Okay, two more examples here. Multiplying. This time it wants me to multiply f times g. Remember when you put variables next to each other like this, we're implying multiplication. Okay, so it wants me to do f of x times g of x. So f of x is 3x minus 5. Again, using parentheses here, g of x is 2x plus 4. You guys might recognize this. We can basically FOIL or double distribute here to get to our answer. So we're going to start by taking 3x and distribute it to each term in the second set of parentheses. 3x times 2x makes 6. Well, you can think of this in parts as well. 3 times 2 is 6, x times x is x squared. So that is 6x squared from our first term. We also need to distribute our 3x to the 4. That gives us 12x when we multiply 3x times 4. Okay, we've distributed the 3x. Now we need to distribute the negative 5. Negative 5 times 2x is negative 10x. And negative 5 times 4 is negative 20. So we've now multiplied them together, but we do have some like terms here. X to the first power and x to the first power can be combined. So how many x to the first powers do we have? Positive 2. I guess I'll just underline since my boxes are terrible. But this would be our final answer. Okay, last example. I know this is very long. Thank you for hanging in there. Last one again, we're going to multiply, but they're making it a little more complicated for us. It wants us to do g of x times h of x, where g of x is the 2x plus 4. Again, we're just getting this from above to substitute in. And h of x is a quadratic. So this has more than two terms. And notice this won't spell FOIL. If you're used to FOIL, first, outer, inner, last, this is not going to work. But again, we want to think of this idea of just distributing everything in the first set of parentheses to everything in the second. So we're just going to start with 2x. 2x times x squared gives me 2x to the third. 2x times 3x gives me 6x squared. And 2x times negative 5 gives us negative 10x. Okay, I'll change colors. Maybe they'll make this a little easier. So we distributed the 2x to everything in the second set of parentheses. Now we're going to distribute our positive 4. 4 times x squared gives me positive 4x squared. 4 times 3x gives us positive 12x. And 4 times negative 5 gives us negative 20. So the last thing we need to do is combine our like terms. Okay, so I don't see anything else with x cubed. We always want to write this from the highest degree or highest exponent on our variable first. So 2x cubed. We do have two terms with x squared, though. We need to combine those. That gives us 10x squareds. We do have two terms with x to the first. That gives us positive 2x. And lastly, we have our constant negative 20. So our answer when we multiply those two is a cubic function, 2x cubed plus 10x squared plus 2x minus 20. That's it for today. Thanks for listening.